And thank you, everyone, for attending. I'm like gobsmacked by the turnout. I'm very flattered. I'm sure the free dinner had nothing to do with it. So welcome to my talk. Our topic today is custom web performance metrics, aka measuring what matters. Also, feel free to yell at me to try to speak louder. I feel like my voice is kind of feeble sometimes. Hopefully you can hear me in the back. Anyway, before we dive in, a little about me. Sergey kind of got the ball rolling, but my name is Terry. I'm based in Brooklyn, across a river, I guess. And I work at Etsy, which is a global e-commerce site for mostly handmade and vintage goods. And I've been on the web performance team there for 3.5 years, give or take. And before that, I worked at other teams at Etsy, and then I worked at Yelp for a few years too in San Francisco. So on to the talk. So there are 3 main things that I'd like to touch on today. First, what do we mean by custom performance metrics? Second, why are they useful? And third, kind of the bulk of the talk, like how do we implement them? So first of all, what are we talking about when we talk about custom performance metrics? I think the best way to understand it is by going over their counterpart, the standard metrics you see when you Google web performance, which I'll call common metrics here. So I was figuring when I made this talk, there are probably at least some of you who are totally new to performance. Maybe you wandered in off the street. And so this part is kind of geared towards a beginner. I figured I should spend a little time going over the basics. So just bear with me if you know everything about web performance already. So common web performance metrics. These include what you see here, things like time to first byte, down content loaded, page load, etc. All good examples. Typically, these metrics are defined and implemented by browsers. You can kind of get them from Chrome, Safari, Firefox, and so on, just kind of out of the box. There are variations. Not every metric is available on every browser and so on. You can't get INP on Safari, but that is the gist. Many of these follow along a kind of timeline or life cycle that starts when your user first tries to navigate to your site and ends when all the resources on the page have finished loading. This is a very complicated timeline. I realize the font is very small, but don't feel like you have to read this. This is kind of for reference. But beyond this timeline that you see here, there are other common perf metrics that we care about that, don't live on the timeline. For instance, you can count the number of long tasks or times when the browser's main thread was busy for over 50 milliseconds, for as long as the page is open. So some metrics like that are INP or cumulative layout shift. You can continue to measure, for as long as the page is open. We'll also specifically often hear and talk about core web vitals, the 3 main metrics promoted by Google that are meant to encompass the most important aspects of web performance. Oh yes, I love this little GIF. These include largest contentful paint, LCP. This is the point at which the main content on the page has loaded. Oh yes. This is not real, don't worry. This, unfortunately, is an example of cumulative layout shift. Quite dire, but also quite funny, it's a measure of visual instability. So layout items jumping around as you scroll.
Successful
yeah.
order, right?
Very successful for the company, I guess. Or I feel like when you're reading an article, and an ad loads in and, your text jumps down, that's layout shift. And the third core vital is interaction to next paint, which is the longest time between a user interacting with your page and the page actually responding to that interaction. So core web vitals. Okay, so now that we understand common performance metrics, let's define custom performance metrics in contrast as developer-defined and site-specific measures of web performance. So this can include metrics like, when did my product image appear on the page? How soon was my video playable? How long did it take to display results after a search input? Time to first tweet, pinner wait time. The last 2 examples are real from Twitter, or formerly known as Twitter, and Pinterest, respectively. So that's kind of what they are. But now let's talk about why we care. So we know that in general, it's important to monitor web performance, right? That's the whole purpose of this meetup. Because we want to be able to answer the question, is my website fast and therefore usable and pleasant to visit? If performance metrics are degrading, getting slower, taking longer, You can take this to mean that people are having a tougher time using your site, which can lead to downticks to other metrics that you care about, like number of purchases, engagement, bounce rate, etc. So performance is important. Yes. Well, yeah. I'll kind of talk about the common metrics. Well, okay. The existence of established, sorry, that's not a good segue, but anyway, the existence of established common metrics is great for a few reasons, like these core web vitals. So one benefit is that industry standards have emerged around like what is good, what is bad, like what is good LCP, what is bad LCP. You kind of get these thresholds for each metric, so you can judge yourself and your site's performance against those. So if your users are consistently landing in like the poor bucket, you know that it's time to invest in improving performance. So like the objective standards. Another great reason for these common metrics is that they give people a common language to talk about web performance. If you say like this website feels slow, you know that could mean a lot of things, and it's not clear how to go about responding to that, fixing it. If you instead say, you know, it took 800 milliseconds for the browser to respond to my button click, that's INP, interaction to next paint. We know what that means, and there are established ways of tackling that issue. You know, Google INP help fix SOS, and you will get helpful guidance about that. And then thirdly, it's great to have common performance metrics because it lets you benchmark your site against competitor sites. This is something that we do at Etsy a lot. Yes, was there a question? Or?
No, I'm just 1 second versus 5 seconds.
Oh, yeah. This is, so I was going to say, this is, okay, well, this is easy, especially thanks to the Chrome UX report, which is kind of a public data set of performance metrics from Chrome users, so real user monitoring data, aggregated by domain. What you see on this slide is Etsy versus Amazon. This is something that we look at Etsy a lot. Sadly, you see a lot of the yellow for Etsy. Our TTFB is generally kind of bad. But yeah, the existence of like the common metric here, time to first byte, lets us compare ourselves. And you know, we can show this graph to our CEO, and then he can be like, yes, we need to make this faster. We need to beat Amazon. You know, it's compelling. But I would argue kind of the motivation for this talk is that it's not enough to look at just these common performance metrics. A few inadequacies, so like the cons after the pros that I listed, are as follows. So first of all, this generic plus opaque bullet point. The commonness of these metrics, the way that they're built to accommodate every web page, also makes them kind of opaque necessarily. So you might see that interaction to next paint has increased on your website, but at least without adding some extra instrumentation or like kind of looking at the attribution of that, you don't know if that lag was associated with a really important user interaction, like adding a product to your cart, or a less important one, like expanding an optional information section. So the metrics kind of make assumptions about the most important measurable aspects of user experience without taking any specific product knowledge that you have as the developer into account. And sometimes those assumptions are wrong, occasionally, which you can see in this example. On this website, the largest contentful paint element, which is kind of taken to measure the most important thing in the viewport, the biggest thing, tracks the appearance of the pop-up cookie instead of the actual page content. So the most important content is your text and your title there, but LZP will often just kind of measure this little pop-up that we don't care about so much. Furthermore, most of our usual performance metrics assume a traditional hard page navigation, which is to say a full browser refresh that sends back new HTML to the user, often fetching new data, as opposed to a soft navigation, which is often like client-side JavaScript, maybe fetching new data, maybe not, kind of partially or fully re-rendering the page as a result. And we often can't use the usual metrics to capture data from that kind of soft navigation within a single page app, like one that's built fully in React or Vue. I have an example here from Etsy. I feel like Etsy, Etsy is all I know. Etsy is all I think about. So you're going to hear a lot of Etsy tonight, so just be prepared. This example shows a section of Etsy that we call the seller tools. It's for like people who sell on Etsy, obviously. Most of the site is built on traditional hard navigations from page to page, but not this section. This is our seller sub app, which is built as a single page app. And so in this is a trace that I took using the Chrome developer tools. In this trace, I landed on a seller tools page, so there was kind of an initial hard navigation, and then I visited another page, like within another seller page, and that's a soft navigation. Hopefully that makes sense. I've always found the performance tab to be a little overwhelming. There's a lot of information in there, but I'm going to zoom in on like two parts. So I'll draw attention to this first part. This was the hard navigation. There's a wealth of metrics that are automatically instrumented and collected here. So you see first paint on there, first contentful paint. They use the acronyms, but DOM content loaded is on there, largest contentful paint, and page load. And then later on, there are absolutely no metrics out of the box, at least for that soft navigation. So we're kind of in the dark there, you know. Now there is some work occurring in this area. Google, for instance, is, as I understand it, in between a few origin trials to automatically measure core web vital performance data from soft navigations. That is still in development, so maybe in a year or two. And there are third-party products like Boomerang from Akamai that will attempt to bridge this gap with more or less configuration required. Yes. So even beyond your single-page apps, I just added this because I think it applies beyond single-page apps. Oh yes, this is my favorite test listing at Etsy. Yes, I think there's a similar blind spot even if you're not in a spa. If there's meaningful content that appears after that initial page load, after that, you know, request lifecycle, kind of like a long-lived experience is what I'll call it. Things that occur long after, you know, your largest contentful paint, DOM content loaded, page load lifecycle, after that has passed. This is our example from Etsy. So a super common pattern for us is like, we'll asynchronously load any components that are below the fold that would otherwise kind of slow down our initial render. Like these recommendation modules, they go through a lot of like machine learning layers and stuff. They take a long time. So we'll kind of save fetching those for later. So if you have the question, like how long does it take from when we request this more from the shop component to when it actually renders on the screen? Well, without custom metrics, we just don't know. So the built-in performance metrics tell us a lot about how fast like the watermelon cat component at the top of the page loads, but nothing about his friends, pumpkin cat, avocado cat, and bunny cat. Finally, third point, and this is kind of more nuanced. But I would argue that existing perf metrics often require a certain level of technical expertise to understand and communicate. So if you tell someone less familiar with performance, maybe someone in a non-technical role, that like largest contentful paint took a certain amount of time, you might get a blank stare like, what is that? Is contentful even a real word? But if you instead create a custom metric that's something like, you know, main product image took X milliseconds to load or to appear on the screen, it becomes much more accessible information. And it's much more obvious why you should care, why you should make it happen faster. In contrast to these drawbacks or cons of common performance metrics, your custom performance metrics are, I guess can be, specific, informed by your product knowledge of your site, adaptable to single-page apps and long-lived experiences, and kind of accessible or like as easy to understand as you want them to be. The asterisk is like, you can make more arcane, technical, complicated custom metrics if you wanted to, but you can also make ones that are just like product image loaded. All this is not to like bash your common performance metrics. They're an incredibly useful tool for all the reasons that I specified, just that there are other tools in the toolbox to help us get the holistic view of performance. And custom performance metrics can be an alternative or like an addition to your common metrics. And you can often use them kind of in tandem, like use your custom metrics to understand your common metrics and diagnose regressions and so on. All right, now I want to give some concrete examples so you can kind of see how you can implement these on your site now that you're all convinced. So, unlike the big list that I had initially of all the regular performance metrics, kind of the nature of customness means that I can't just give you a list of them, what they are. It's up to you to define them for yourself for your own website. But there are some established ways of implementing the metrics, which I will go over now. To illustrate some of my examples, I know you're sick of hearing about Etsy, so I designed a fake site where you can find and adopt cute pets in your area. It is called Petsy. It has some basic features. It has our main product image. It has a title, call to action, this little adopt button, and a few other kind of secondary features. All right, anyway. So the first custom metric implementation method that I want to talk about is called the element timing API. By the way, for each of these, I'm putting browser support in the bottom right corner of the slide. If you refer to the slides later, it could be useful. So element timing, this is a browser API that measures when specific images or pieces of text have loaded. And it's very simple to use. You can use it by just adding like an element timing equals element label attribute, like you see here, to the HTML tag. So common use cases for this include, when your major images have loaded, your hero banner, your product image, or important text like your page title appears. And so this lets you be opinionated about what the most important elements on the page are, rather than assuming that the automated largest contentful paint metric captures the data that's most important for you. At Etsy, for instance, kind of like the example that I had a few slides back, we've observed that most of the time when we're able to log largest contentful paint on our kind of main product page, it is what you expect. It's the big image, but about 5% of the time, the LCP image isn't that main product image that we would expect. Sometimes it's the page title, sometimes it's some other random image. It's weird. The LCP element often varies based on factors like screen size or that cookie banner and so on. So if we, the site owners, know that the product image is the single most important element for our users on a given page, why not track that load time directly, like we're doing here? And if you want to go beyond that, if you want to get a fuller understanding of page performance, you can kind of instrument beyond just that top most important element on the page. So here you can add instrumentation, well, in this example, for like secondary images, subheadings, review text, et cetera, et cetera, et cetera. And that is all enabled by the element timing API. Like why you limit yourself to one thing. You could do 3 things, you could do 10 things. At some point it becomes too much, like 100 is too much, but go beyond 1. You could choose to track the appearance of your site logo, your page title, main image, first thumbnail image, to ensure that none of the page's main features slow down over time. Yeah, and as I said, it's very simple. It's like one attribute, it's one HTML attribute per HTML element. So super simple. Note that this API is currently only available for images and groups of text nodes. So like paragraph tags are fine. Like div tags or the container tags are not eligible, although there is a polyfill for this that Sergey pointed out to me, which is linked in the slides. Okay, and now this is super important. The performance observer, big topic. Once you've adorned your HTML elements with element timing attributes, to collect that data, you'll want to instantiate a performance observer like so. So I think of it as kind of like an event listener. So for element timing data in particular, you'll observe streaming like resource performance measurement events. The buffered flag that you see here lets us also include any, it's kind of magical. It lets you include any performance measurement events that occurred earlier. So like even if your main product image loaded really early, which is great, good for you. And then you kind of run this JavaScript code after that, it'll still be able to access the data from that earlier image load, which is amazing. So in this example, we're logging data to the console. In real life, you'd probably want to aggregate the data, send it off to be stored, analyzed separately, maybe send it to a third party, I don't know. So I've included these kind of gray code slides throughout, but a lot of them rely on the performance observer. So the slide is important. It's worth pointing out, I didn't show an example of it per se, but you can also use the performance observer to collect like your common perf metrics as well. You can observe for like a large contentful paint type, for instance. And again, note the browser support in the bottom right. So it's like on all 4 of our major browsers. Okay, so that is element timing. Simple, right? Just a few changes to your HTML, a few lines of JavaScript, and off you go. So next up, I want to talk about the user timing API. This is an API that lets you measure the passage of time relative to navigation start, well, among other things, via this call like performance.mark in JavaScript. So for instance, if you want to know how soon a user is able to perform an important action like clicking on your checkout button, you can add a performance.mark call after the JavaScript setting up an event listener for that action has completed, which is kind of what you see here. And then you can collect that data using the performance observer again, like so. Here we are observing for type mark. And then for each of those entries that come through, we're just kind of logging the start time. Simple. I don't know. You can read the code. You can also measure the duration between 2 arbitrary points in time, or like between 2 marks with performance.measure. So if you want to know how long a certain task took to complete in isolation, not relative to navigation start, you can use performance.measure. Here, we have this mark that's like button JavaScript began, then we're doing our thing, like, you know, adding a bunch of event listeners and logging for people clicking on this adopt button, and then you're doing a performance.measure that will capture how long it took to actually complete that JavaScript action. And then you look at the duration property of the resulting performance entry using a performance observer. So like same thing, you've seen this. This is a simple example, right? But there's a lot more that you can measure with the user timing API. Things like when critical styles or fonts have loaded, and how long it takes to fetch new data via an AJAX request. These timings have also been around for a while. I'll point out, yeah, like pretty broad support in that bottom right corner. And that means they're pretty well integrated with existing performance tooling. So for instance, they're collected automatically in timelines in the performance tab in Chrome Developer Tools, by tools like Web Page Test. And since the browser support is kind of broader than it is for element timing, which is here, you can see this is sadly not available in Safari or Firefox. So you can, where was I? You can kind of use this as a fallback API to still collect custom performance metrics, even for those areas or like browsers where element timing is not available. All right, that's our second API. Now let's talk about our third, the resource timing API. Now the typical page has a ton of resources on it, like assets, beyond just the plain HTML, right? Like Petsy is no exception. This example page is loading at least 5 images plus some CSS, JavaScript, a font file for our signature font. And resources like these are a really important factor in web performance. So in fact, some of them, like CSS and font files, are by default render blocking, which means they prevent the browser from displaying anything until they're fully downloaded and processed. So we care about those for performance. And it's obviously vital to understand as much as possible about them. And that is where the resource timing API comes in. To simplify, we're just going to consider the image resources on this example page for now. Unlike the other metric implementations that I've touched on, you actually don't need to go in and instrument your page resources especially to tap into this API. Like you don't need to add, you know, resource equals whatever in the HTML. It is available automatically with a performance observer. You can access timing data, of course, like how long your resources took to download, but there's tons of other information available as well, including size information, you know, how many bytes did your user actually have to download, aka transfer size. So I've annotated each image here with the transfer size associated with it. And you'll note that the transfer size for this main image, the big, like Reggie, our buddy, is 0. And that is because transfer size takes browser caching into account. So if you've seen that main image elsewhere on a different page on our site, maybe you've kind of loaded this page before, I don't know. And caching is enabled, your browser won't have to incur the cost of downloading it again. So this is great for web performance. It's kind of a free image. Anyway, it is now really easy to take this research timing API and make a custom metric for yourself, like total transferred image bytes. And that is what I've done in this example here. This is like heavily inspired by what we do at Etsy. So you can see here we are observing type resource. And then in our kind of callback, we're filtering down to just images. It's like initiator type equals image. And then kind of summing the transferred bytes. And you can repeat this pattern for like CSS, JavaScript, fonts, etc. For a better grasp of the total impact your resources are having on the page performance. So I was saying at Etsy we do this like specifically for storage space reasons. Like you could get super granular. You could just save the entire performance timing, like all the URLs, like on an individual level. We instead do aggregates because just for storage cost reasons, like this can get insane. Yes. Anyway, these numbers in particular often help us track down the source of like unexpected shifts in other metrics. Like if we see, oh, first contentful paint has doubled, you know, maybe someone accidentally also doubled the size of CSS on the page or something. Yes, so very powerful, very helpful. So those are kind of the three main browser APIs that I wanted to talk about, like element timing, user timing, resource timing. I wanted to kind of go off on a tangent a little bit. I think I included these slides because I've been thinking about this a lot at Etsy recently. So let's talk about backend metrics and why they're important. So I feel like oftentimes when we talk about web performance metrics, we are talking specifically about front-end metrics, measurements taken after the client starts to receive data back. And we'll also sometimes talk about ways to improve, like the networking step that you see kind of initially here. Before your request hits your backend server. So let's focus on the time like before hitting your server and kind of after your server responds. Makes a lot of sense, right? Because despite differences across browsers and devices, we have like established ways to measure and talk about the various like connecting, downloading, parsing, rendering, executing tasks that happen in those two spans of time. And also just the nature of it, like information is more accessible, like from, if you're taking the information from the front end, like you can gather a wealth of this kind of performance data from your own website, but also from any publicly accessible website by using tools like web page test. Yeah, you are like empowered to collect the time to first byte from your competitors and so on. That is just freely available information as long as you can access it in your web, like in your browser. But like in this system, the backend remains kind of a black box. It is generally inaccessible to site visitors, right? Like you need to have access to the source code to understand what is happening, like between receiving the request and getting your response back. And also each backend is implemented differently, right? Like some are static sites, some are implemented with like content management systems, some use popular web frameworks like Ruby on Rails, et cetera. Some return just data instead of HTML, and then you'll kind of dynamically render stuff on the client, and so on. Like each one is unique, like a snowflake. And so this means that beyond just the basic like total server response time, like how long was it between request and response, there are no universal performance metrics for the reasons that I've said. And yet backend performance, this kind of goes without saying, but I'm going to say it. Is one of the most important and impactful factors to optimize, right? Because if you think again about the timeline that most major performance metrics follow along, if your server is responding quicker, that means that all the other request lifecycle metrics that fall after, you know, from first paint to page load will also happen faster. It's like this virtuous cascade. So yeah, we want to make server response time faster, and in order to do that, we first need to understand what's happening. So enter custom backend performance metrics. So if you maintain a web application, it is up to you to instrument it so that you can understand what's happening on your backend and detect and fix latency regressions. This requires a deep understanding of your application architecture and the ability to name and define kind of, in a way, lifecycle metrics along the path between receiving and responding to a request. Etsy, for one, uses an in-house web framework that we've broken down into distinct steps that you see here for like routing, data fetching, processing data, and rendering views. Those are kind of the big four for us. And once you've established custom backend metrics for yourself. It's just a matter of associating those with your front-end metrics. And I think this is key as well, like seeing your back-end and your front-end together as one. This is really useful, like putting them side by side, because then you can see the influence that your back-end has on your front-end. And we're better equipped to trace front-end metric degradations, like our LCP mysteriously bumping up back to maybe a specific back-end change that prompted it. Okay, and now bringing it back, tying it all together. If you're already collecting performance metrics on the client side, like I've demonstrated with kind of the previous slides, if you've already got your element timings and your user timing set up, one of the best ways to loop in information from your backend is the server timing API, which is my next custom metric implementation method. Oh yeah. Ooh, go server timing, yes. So am I. Oh yes. So the server timing API, it lets you send kind of bits of numerical or string information as a response header in your server response, and then you can access that from client-side JavaScript. So it can look kind of like this. Like here we're sending, routing, data fetch, data process, render with like little timestamps or like duration links for each one. And the cool thing is that you can, well, as I said, you can access that server timing data on the client side using your old friend, the performance observer. So here we are observing type navigation. These are response headers that are on your main page response. And then you can just access, kind of key into the server timing. Oh, yes. Well, yes.
Any particular reason you're sending that to the client? Would you be more interested in taking the data from the client side and eventually bringing it back in-house towards where the servers are and aggregating?
Like for us, we're already collecting a bunch of front-end client-side perf metrics. And like it's helpful, or it's like less complicated to put, just put them together in one little like event or like packet of data. Of course, like this is not, you don't want to put anything too like sensitive or like security concerned, like because these server timing headers are now publicly available to anyone who's looking for them anyway. So don't put anything sensitive in there. But like your basics. At its least, it's useful to just kind of put them all into one little packet. Yes, so here we are console logging them again. But again, you can collect them in JavaScript and do whatever you want with them. One thing that is maybe even more powerful and cool about the server timing API that we've used a lot at Etsy is that you can use it to collect data from not just your own backend servers, but also from any other request sources on your site. So Etsy, like many sites, uses a CDN, content delivery network, to send resources like images, CSS, font files to our users. One of the many performance benefits of using a CDN, of course, is that they maintain caches for frequently requested resources. Images are crucial to e-commerce. Etsy is no exception to that. But like a kind of unique problem is that Etsy has a super long tail of images because we have millions of products and then people like upload their own like customer images of themselves enjoying their like, I don't know, like bespoke jewelry or whatever. So we have that long tail of images and we want to ensure that we're sending users images that are already cached by our CDNs whenever possible. And we want to know like when our cache rates go down. So we've configured our CDNs to attach response headers to image assets. It's simplified, but kind of like what you see here to tell us whether an image was cached by the CDN or not. So in this example, we have 2 cache hits, which we know from the server timing header. We have 2 cache misses. And again, performance observer, you know the drill. In our performance data gathering JavaScript, we loop through all the detected image resources, count how many were cached and how many weren't. And this informs our understanding of pagelet as a whole. This particular example we used at Etsy, we noticed a degradation in page load, which includes time spent waiting for all images to download. And then so we added this instrumentation with the server timing API. This was on our search page. And thanks to this data, we were able to tie it to the addition of a bunch of like as yet uncached images. Like I think we switched from like a rectangular image to a square image, and the square images were totally new. And therefore uncached by our CDNs. So this kind of let us understand what was happening. So to sum up, the server timing API is super cool. All right, so that's kind of all I had to say. But to wrap up, with custom performance metrics, we've gone over what they are, kind of why you want them, and how to do at least some of them, or like a few ways that you can implement them. So I hope I've convinced you to consider measuring what's most important for your specific users on your specific site to glean a more holistic view of its performance. Finally, I mean, I consulted various websites to make this talk, but I've kind of listed the main ones here. If you're interested in learning more, yes, take a picture. But I think we'll also kind of send these slides out like in a follow-up email. And thanks for watching. Thanks for coming. That's all. Thanks, everyone.
That's for recordings.
Okay. So I'm wondering, like, so your role at Etsy and I guess your entire team role, how much of that touches like back end, like performance concepts, or is it mainly front end?
It comes and goes. Honestly, like our ambit as the performance team at Etsy is super broad. Historically, we've been more front end focused, but I would say basically since we started using this third-party tool called Honeycomb, which is like a distributed tracing tool, lets us see kind of all the requests that are happening, other kind of, and so on, like in our backend requests. We've been able to delve more into backend performance. And I personally have spent a lot of the past 6 months like helping to optimize backend performance on like our listing page or our product page and so on. So it varies, but yeah, it is useful information for sure.
Hi Terry, thank you for presentation. Really cool. Question to you: when too much metrics are too much?
Yeah, that is a good point. And again, that is something that not to tie it back to Etsy, but we are contending with that as well. I think it's important, especially if you are a performance engineer, or like to define a hierarchy. Like one way to think about it is that you will have like your top line metrics or your like reported metrics, like core web vitals. Those are the things that you tell your CEO about, that you make sure that that like product teams know about and maintain. And then you have like diagnostic metrics, which you can use to understand like, why is my LCP tanking? And those may be more specialized. Not everyone at the company needs to know what they are. And that is a good role for custom performance metrics as well. So like helping you understand.
Hi. I'm curious, so you've collected these metrics, and they're, coming through your performance observer. What do you do with them then? Like, where do they go? How do they get aggregated? What decisions get made?
Good question.
Yeah.
So it varies. Many companies, or I know many websites will aggregate these metrics with a third-party tool like SpeedCurve, perhaps Catchpoint, I'm not sure. At Etsy in particular, we have like homegrown tools for everything. So the packet of performance data, we call it events, is just it is sent through, there's a complicated system. Oh, Sergey's nodding because he knows. It's a large company. No. Like the performance stuff in particular, it ends up in like a big table in BigQuery, like a kind of SQL table. And then we will create one like super common use case for it is like, most of the product work at Etsy is run via experimentation. We have like an in-house A/B experimentation platform. And because the performance data is super accessible, like it's just there in a table, it's right next to another table that has all of our like conversion data and stuff. It's really easy to like join it and say, oh, this experiment is taking conversion. We also see that it's making the page twice as slow, so we can kind of connect the dots like that, which is nice.
But you do need to connect the dots.
Yes.
There's no way out.
I've picked up a lot of SQL over the years.
Yeah, thanks for the talk. It was great. Especially, I was really interested about the image caching part where you were going into the server timing part about the hit and no hit, which implied that you guys are you guys running your own CDN or?
No. It's we have not created our own CDNs, but we're able to configure our CDNs like responses, like how the responses leave our CDNs, and we are able to like go in there, add special configuration to like add our server heading timer.
Okay.
or yeah, server timing header. Yeah. I was gonna say, like, I think so we use Fastly, well, we use two CDNs, Fastly and Akamai, for various reasons. Like, I think in both of those, like, consoles or UIs, you're able to see, like, as a whole, what are your cache hit rates and cache misses. But I think you can't narrow it down to, like, specific pages or specific A/B experiments that are running, things like that, because it's a separate tool. This way, again, we can, because it's kind of our data, we can, track it down to a specific A/B experiment that is running on our site. Does that make sense?
Yeah, and the upside to using the server timing header for tracking hit or miss versus like the bespoke CDN header is it just comes in through the performance observer.
Yes.
And then it just aggregates it all the same way.
Yeah, it's
Okay.
so easy.
Yeah, great. Thank you.
Yeah, I just want to add that back to your question. This is where sending that back to your backend is almost impossible, right? This is a good example of sending it through the RUM is actually a better approach.
Yeah, exactly. It's true.
So I just wanted to also add to the gentleman's question about why would you collect all the backend information on the front end is because you can also send this information to your BI analytics, like Adobe or Google Analytics, whatever you're using.
Etc. Yeah.
And there you can combine the performance metrics with your KPIs and measure that. I have a question now for you, Terry. First of all, thank you for the presentation. But the question is, are you using CDN for the pages themselves? You mentioned using a CDN for static assets, JavaScript, images, right? But what about the pages themselves? They're pretty static in themselves, right? With exception for some of the user content here and there, but majority of the page would be static.
You would think so, but sadly no. Also, it's sad that I think Paul, our other like co-organizer, is on vacation, and he is kind of our CDN guru at Etsy, so he would have a better answer. But no, we like our HTML requests do go through our CDNs, but they're not cached. I think the main reason for not caching on the edge like that is it again goes back to our very complicated in-house experimentation platform. Like, we want to make sure that all of our experimental features are like logged the same way and consistently in our backend, which would not be guaranteed if we're serving cached versions of the HTML to our users, I think. And there are like personalization aspects on there too. There's a lot of like personalized recommendations and so on. So maybe bits of it could be cached, but we haven't figured that out.
So building on this, right? Going back to your screenshot of Amazon versus Etsy performance.
Oh yeah.
And the KPIs in your BI data. Wouldn't you say that the benefit of having A/B testing, which prevents you potentially being one of the main reasons that prevents you from being able to cache those pages and return them faster, because then there is no server processing, and just decoupling some of the elements which are user centric and maybe synchronously loading those small pieces. Wouldn't that be the cost of having that slower performance than Amazon, for example?
Definitely, yeah. That is a major factor. Part of it is that, like, frankly, our team is fairly small at Etsy. We don't have a lot of resources to devote to like figuring out a better caching strategy. But yeah, that is certainly the case. This is also a reason, like, I think we've explicitly not opted into like BF cache, the backward forward cache, which is it's similar to like full page caching, I think, because of this. No, it is a very good point that you're making. It's just hard to sell that to the rest of the company as a whole when everyone is so hyper-focused on the A/B experimentation platform, making sure that nothing breaks or like changes too much, I think.
When decisions are made using A/B testing platform that degrades performance by itself, how do you prove that you need? That's A/B testers. Yeah, I mean, well, they already laid some people.
You can create another.
There are solutions. You can refer to my talk last month about that. Oh, sorry, 2 months ago about that specific problem. But it's a hard thing. Any more questions, folks? No? One more. Okay. And then we'll open to network.
I'm sorry, the last question. I gotta get to the bottom of this one. So the data that you received, do you build like a dashboard for different users?
Yes, we do. Etsy is like relatively old, and we have a lot of things built up in-house over the years. And one of those is an internal platform that we use to show data, especially experiment data. We call it Sonic because Sonic like goes fast, as I understand it. Yeah, we'll show a variety of dashboards, kind of high level, like we usually foreground like the P75 is, or the 75th percentile is kind of like a good kind of tranche of users to focus on, and then we'll show more detailed data kind of across the percentiles, how things are, comparing different experiences within an experiment, and outside of experiments, we'll show kind of historical data over time, so you can see bigger trends coming and going. But yes, we have built up the whole thing. I'm not sure if we were starting from scratch again, we would probably go with a third-party tool, but it's already built up so much, it exists, and there are trade-offs. There are pros and cons to rolling your own versus buying a third party. I would say there's no collecting too much data. There is such a thing, I think, as like showing too much. Like I think you want to start at a high level, like these are our top level metrics, things are going well, things are going poorly. If people need to, give them the tools to like dig in to other data, more metrics, et cetera, to figure out what's going on. Yeah, collect it, but don't always show everything. That's my philosophy.
To simplify that, we built one metric, right?
Yeah. Oh, yeah,
we
we
have
did.
one
Yeah, we have
metric
an
too.
aggregate metric.
An option for just, if you
The
want to look
score.
at one number, here's another.
Yeah, exactly. If 7 numbers is too much, we'll show you just the one number.
Is there a way in general to, say, measure and report connection speed?
I think there is. Well, Sergey looks like he has an answer. I think there is, right?
Different quality of data. Like there are some challenges with it. In fact, I think there is standardization going on right now that changes that. I think it's called effective connection speed was the old way of reporting it. I might be wrong with the names of specific APIs, but there was an API that reported the speed. However, it was quite inaccurate. And the new API, again, if Paul was here, he would give you exact names and numbers.
He's in Italy.
And phone numbers of people to call if you have questions, so there are options there, yeah. And some CDNs provide similar information actually as well, because they do try to measure that. So some of that is available. Requires a lot of CDN magic, not available out of the box for sure. Fastly does some of it, yeah, and probably not out of the box either. Okay, thank you, Terry.
Thank you.